Hi and welcome back. Imagine you are building a product that answers questions based on retrieved documents, like company policies or support guides. You are using RAG, a system that generates answers based on retrieved documents. But here is the challenge: how to make sure that answers are correct or if it stays faithful to the retrieved context. In this tutorial, we are going to show how to evaluate RAG system both in terms of faithfulness and correctness. We are going to set up mock RAG system, then we are going to generate synthetic test dataset and see how we can build a report which tackles both correctness and faithfulness, so that you can evaluate the quality of your system before it reaches real users. Let's dive in. And evidently we believe in test-driven development. This is why we will start from project generation, and it will be the place where we are going to generate and store our test dataset as well as quality reports. Let's quickly do it in interface. I'm going to call it LLM course. RAG. Let's also pin it. And here we go. In this project, we will generate test synthetic dataset to use it for a RAG system evaluation. I will open up the project, then navigate dataset, and here I can hit button generate dataset. Here we have plenty of options, and I'm going to go for Q&A from documents. That's because we are building RAG system. I'm going to ask Evidently to generate for us pairs of questions and answers, and in this case we are sure that answers will be correct because it's the way how we build those datasets, and we will be able to use this dataset to test our future RAG system. Let me hit this button, and I would need to create the dataset name and upload the file. I would call my dataset testing Q&A, testing questions and answers, and let me drag and drop my file here. It's done, so I'm going to use a small part of Evidently documentation related to LLMs. I believe that's quite interesting. And well, actually I don't need really big data set because I want to keep it brief, but let me do the following. I'm going to ask Evidently to generate for me 10 pairs of questions and answers, and then I will select maybe 5 which I like best. And here is also a checkbox to include context, but in my case I don't really need that. It will be enough for my metrics to just have pairs of questions and reference answers, so I'm not going to hit it. Now I would need to create my secret because I'm going to use LLM to generate these things. Let me quickly do that. My secret is here, so I can proceed now. You can see that it instantiated a task, and as soon as dataset ready, we can hit the button open the dataset, and here is our draft. Let me quickly go through questions and answers one by one as an expert so that I can select which pairs of questions and answers will be a good match for my RAG system so that I can only test it against selected pairs. I don't really like first question, I'm going to drop it. I don't really want the second one. And the third one actually. Yeah, this one is okay. I like this as well. No, I don't want this. This is okay. Yeah, I like the one about text preset. Text ones, I mean. Yeah. And I'm going to drop this one. I think I selected 5 best questions. Let me now drop selected ones. And I think now I'm happy with my dataset, but again, I would recommend you to invest your time into curating this dataset so that you are happy with the pairs of questions and answers. And actually, maybe you want to add something yourself. In this case, you can just add row and formulate question and answer yourself. Also, you can edit every part of the dataset, but in order to keep things brief, I will just finish here. And now my dataset is ready. Now it's not draft anymore, it's dataset, and I have dataset ID. I will copy it to use in my Python, and let me go to the code part. So now we have testing dataset and we are set up to build our mock RAG system. First of all, in order to build the RAG, I would need to import quite a lot of things and I'm going to need to install many libraries. I already installed mine, but to make it easier for you, I want to mention that we are going to use Langchain, as well as Langchain Community and Langchain OpenAI, because we are going to use it to create our vector store, as well as Faiss, it's Facebook AI semantic search, so make sure that you have all those libraries installed. I already have mine installed, so let us try to import everything. Yeah, looks like we are good. So yeah, I'm going to use a couple of standard libraries like random, requests, time, OS, and pandas, as well as things from Evidently, like a client, and a lot of things to generate dataset, descriptors, and the report. And of course, I need OpenAI to have an access to an LLM. Let me also instantiate my clients for OpenAI and Evidently. And here we go with our testing dataset. So even before I started to build my mock RAG system, I wanted to load my dataset and make sure I have a basis for quality evaluation. That's pretty important when you build a complex system because there are so many different parameters and strategies to tweak. Like what is your ranking strategy? What is your chunking strategy? Like chunking size and overlapping. So there are a lot of things to tweak and optimize for your system. So it's always a good strategy to start from a testing set. Let me access it by ID. And here's the preview of my dataset. So that's exactly what we had in Evidently, right? It's pairs of questions and answers. Okay, so now let's create our mock RAG system. I would start from implementing a couple of functions. First of all, I would need to write a function which accesses my data through the link. I'm going to use part of Evidently documentation, which is available openly by a link. So I'm going to pass here a link. Then with help of response requests get, download the content of this link and parse the text. Then I'm going to use character text splitter in order to build chunks over my data. And then I'm going to generate embeddings with help of OpenAI embeddings so that I can have a vector for every single chunk, and then I will create a vector store so that I can easily search by similarity through my vectors. That's more or less the plan. So it's my first helper. My second helper will be actually search, because the first function will return the vector store object itself, and then I would need to have a function that helps me to find relevant documents in my vector store by query. That's exactly what's happening here. I'm going to use similarity search from Faiss as well. Here is the query I'm going to put as the input variable, right? And I'm going to extract 5 most similar chunks of my data. Then I'm going to combine all these chunks in a single string and return a context. This context will be used in the next function. The next function is actually a generation of my response with help of OpenAI. Basically, this function receives question, retrieved context, and here is the parameter, which is model version, right? And basically what I'm doing here is I'm asking my OpenAI model to answer the provided question based on the retrieved context. Here is the input. So you should just say, hey, here is a context and the question, and I expect to receive a response. Pretty trivial. So that's how you can build your mock RAG system. Basically, that's it. So let us try to see whether it works or not. In order for doing that, I'm going to access my documentation in a TXT format, and let me build vector store on top of that. So you can see there are plenty of chunks. This document is pretty long, actually. Yep. And let me now generate my testing dataset with generated answers as well, so that I can have a dataset which includes questions, reference answers, those things I generated with help of Evidently dataset generation. Then I have retrieved context and I have generated answers. I want to put it all together in a single dataset and then build my report based on this dataset. So yeah, here are my questions. Now my context, and I generated with help of search documents function. Yeah, I have a context. And now let's create generated answers with help of generate response function. Here I'm using the zip, so I have to gather my questions and contexts. Let's wait until my data is generated. Yeah, it's done. And now you have also a list of generated answers. And from here you have two strategies to go with. First is to read through the generated answers, context and questions carefully yourself and decide whether you're happy or not with the results. If you're happy, then great. If not, maybe you can generate some hypothesis of what is the problem and how to fix that. But actually, I personally do not do that in the first place. I prefer first have my report so that I can see some summary statistics and then maybe explore only failed cases one by one so that I understand what's going on much faster. And that's actually the second strategy. Your second strategy is to calculate some tests or metrics for every combination of your parameters, like overlapping strategy, chunking size, or whatever you can tweak for your X system, and then see what are statistics. Then you can go with the best option and still do some manual analysis to understand what's going on. For our case, we have only one option so far, right? It's our mock X system. So let us generate the evaluation dataset. In this case, I'm going to have my question, reference answer, of course. This we have from evidently. Else we are going to have generated answer and generated context. That's my data frame. Let us quickly preview it. Here we go. So yeah, reference answer and generated answer are, well, not extremely long, but you need to read it through. And the context is long, of course, because we retrieve like 5 most relevant chunks. So it's quite long. But luckily, we can create our custom LLM judge. We can import quite a lot of default judges from evidently and build our report with a lot of useful metrics. Let's do this exactly. And I will start from my custom judge, which is contradictions check. The idea here is to compare my reference answer with generated ones and see whether there are any contradictions between those two things. If there are no contradictions, then it's great. My generated answer is kind of similar in a semantic sense to my reference answer. But if there are some contradictions, then I would need to read through it and understand what has happened. I'm using my binary classification prompt template here. Here is the criteria, right? And my categories. So the target is contradictory, non-target, non-contradictory, and if my judge is unable to decide whether it's one or the other, let me have unknown. It's done. And together with this contradiction check, I'm going to use default faithfulness LLM eval, which I can just export from evidently. So basically here I would need to say that, hey, here is my generated answer, here is my context, can you please check if my generated answer stays faithful to the retrieved context. In this case, if you have a very nice ranking, so you always retrieve relevant context, but your LLM is hallucinating and kind of ignores the context, you will be able to see these things. I think to start, it's a good combination of metrics. Let us go for it. Now I'm going to create the dataset from my testing data frame, and I'm going to include 2 of these descriptors, faithfulness LLM evaluation and my contradiction check. Let's evaluate them, and we will see what's going on. So yeah, it's ready. My next step will be preview my dataset so that I can see that all my descriptors are here. Yeah, I can see faithfulness with reasoning, great, and contradictions with reasoning. Oh, and the first one is both unfaithful and contradictory. So it definitely makes sense to actually load it to evidently so that I can see the visual report and understand what's going on with my questions and answers. Let me go for text evals report. Yep, it's here. Yeah, I cannot help but preview some statistics. With faithfulness, it's not that bad. I have only one unfaithful answer. With contradictions, so-so. 3 are good and 2 are not good. Let me load it to the cloud. And in order to do that, I would need to have a project. We already created one. It's the project where we store our synthetic test dataset. Here it is, and let me copy the project ID from here so that I can go back to the code, specify it, and load my results there. It's done. Let us see the results in the cloud. And let me browse my report. I hit Explore, and here it is. Here is our report. It starts from faithfulness, and you already know that we have one unfaithful answer, and also we have contradictions, and in this case we have 2 contradictory answers. Luckily, we have our dataset right here, so we can order our data by faithfulness, by contradictions, and understand what's going on. It is super helpful because you have so many options, parameters, and strategies to build up your RAG system, and if you really invested in generating really nice testing dataset, you can trust it. Then you can find optimal parameters by evaluating quality on top of your test dataset and make sure that you build the best possible option for your users. Thank you for watching.